आज की अपनी क्लास है, as you know, is based on only one topic, which we call it as spring forces. And this particular topic is going to pop up regularly in your syllabuses, and it has a very, you can say, great implication. Okay, and this particular part which we are going to discuss today will involve all the different types of spring forces which we consider now. Okay, how do we analyze horizontal level of spring? Means these spring forces are broken into two parts, two kinds of adjustment we have to see. We have to first see the horizontal type problems, horizontal level questions, and second one are your vertical type spring problems. Is that clear or not? Two types are there, horizontal and vertical. Okay, and based on that, different kinds of questions are going to come. Now, so as we know that, let's take the first meaning first. Let us understand what does the word spring forces mean. So let's suppose if I consider a block attached to a spring. Wait a minute. Let's suppose there is a block attached to a spring and this has a mass m, and imagining that this is its natural length condition. NL means, I call this word NL as natural length. Okay. Now what does this word natural length means? Over here there is no expansion and no compression. Hold on. Over here there is no expansion and there is no compression. Are you able to get me or not? Now what I did in the second stage, I expanded this. Hold on. So look over here. Let's suppose I expanded this spring and I brought it over here. Got it? So you can see that there is some displacement from this natural length state, correct? Of the mass m. Got it? Now see, when I expand by distance x, now you have you seen a rubber band or not? When you stretch it, it goes back actually when you release it. So this is what is happening. Basically, it means that in these bodies, in this solid bodies, there what is happening that between two particles, when you try to stretch the other particle, this particle wants to attain its original state after some time because of van der Waals forces, or you can say intermolecular forces. Is that clear or not? So due to that, same thing is happening over here. When you stretch this mass m, let's suppose I applied some force F and I brought this over here, then this particular mass m is going to experience some kind of force. Now again, it has a nature, as I have told you, means see, there are four types of contact forces: normal, tension, spring and friction. So here also spring is considered, means this what is happening over here, a contact force is going to appear. A contact force appears which tries to take back the spring back to its initial state. Is that clear or not? Back to its which state? Initial state. Are you able to get me or not? Means this spring force which appears over here is along the opposite direction, because you can see that uh, this some force needs to be appeared. If I remove this F, then how does this mass goes back? Because of there is a force which is present opposite to the direction of displacement, and we call it as a spring force. Now there is a nature of a contact force. Any contact force always appears. Keep that in mind. Hey, are you guys wake up or not? Rehan, Abhiraj? So any kind of a contact force appears in such a way. Simple idea is there that they always come into pair. They always comes into what, Balak? Pair. And best idea to draw a spring force is simple. Select the point of contact and draw the force, draw the spring force away from the point of contact and on the spring. Always. How you are going to draw spring forces? Always away from the point of contact and towards the spring or on the spring. Is that clear? Like let's suppose if you consider, if you consider this point of contact, then spring force will be in which direction? This direction. Is that clear or not? Why? Because it is away from the point of contact and towards where? Towards the spring. Say me something, yes or no? Are you will get me or not? Then question arises that, sir, what is this spring force? Now as you can see that when you like, idea is that let's suppose there is some person over here and you want to hit using a rubber band. So the farther you stretch the rubber band, the farther the harder it hits the person, correct? Now this means that as much as I stretch anything, as much as the force is increasing or not, and this happens with the spring also. This means that we can say that this is spring force. Okay, right over here. The force due to spring is dependent on my displacement, but as it is opposite of displacement, why not? And if I remove this proportionality, this spring force is written as minus of some katappa into displacement. This katappa k is called as spring constant, and this one depends on three major property. First of all, uh, this depends on, you can say that material. Second, length of the spring. Third, area of cross section of spring. And fourth point, temperature. Although you can see that this is present in the formula of F of spring, but this is independent of force on the spring and second point, displacement of the spring. Is that clear or not? जग गई बे चोया. हेलो। मैं भी थोड़ा सा ही करवाया हूँ। इज दिस क्लियर और नॉट? मीन्स इधर से ध्यान, लुक ओवर हियर। Simple idea is there. If I want to talk about the spring, how to draw the spring forces, that's what I talked about. Simple. Just select the point of contact, and towards the spring and away from the point of contact, you have to draw the spring forces. Are you able to get me? Again, same idea. Away from the point of contact and where? Towards the spring, you have to draw which kind of forces? Spring forces. Are you able to get me? Okay. So let's start with simple basic problem. Okay. Let's suppose there is, let's suppose I consider this rough surface. Not rough surface. Let's suppose there is this surface and there are two blocks over here. Now, between them, I attach this spring. I don't know. And this block is pulled by a force of, let's suppose, 50 Newton. This has mass 2 kg. This has mass 1 kg. And at that instant of time, it has an acceleration A is equal to 5 meter per second square. Wait on. A is equal to 5 meter per second square. Question is very simple. Find the acceleration of another block at that instant of time. Be fast. Find the acceleration of the another block at that instant of time. Balak's answer. Rehan. श्रुचि। ओबे, जिंदा है श्रुचि? नहीं है? आवाज नहीं आ रहा है तेरा। अनम्यूट करके बोल एक बार। एक बार अनम्यूट करियो फिर बोलियो, ठीक है? हेलो हेलो हेलो। नहीं आ रहा है। अच्छा, ठीक है, तू टाइप कर दियो करियो, या फिर एक बार कट करके ज्वाइन कर। मेरी आवाज तो तुम लोग आ रही है ना? हेलो हेलो। नहीं आ रहा, पता नहीं माइक ग्लिच हुआ है क्या, पता नहीं। हाँ अभी आ रहा है, अभी आ रहा है। हाँ बता, इसका आंसर निकाला तूने? देख ठीक है। स्प्रिंग फोर्स कैसे, हाउ टू ड्रॉ स्प्रिंग फोर्स, सिंपल आइडिया इज देयर, listen to the point, see the point of contact and away from the point of contact and towards the spring draw the spring force. Simple idea, logic. Is that clear or not? Apart from that, no other logic. Okay, and that spring force is equal to just kx. Look over here. Here I didn't mention any k or something like that. See, where is my point of contact? There are two points of contact over here. Correct? One is this, another one is this. So spring force will be from away from the point of contact and towards where? Towards the spring. Here also away from the point of contact and towards the spring it will be there. Is that clear? Like here, this is the direction of a spring force and this will be the direction of a spring force. So in reality, who is accelerating this 1 kg? Spring force is accelerating. Now why? Because this force is not directly present on the spring. Are you able to get me? Can you get my point or not, guys? So therefore, I'll write the particular. First, I'll try to find the spring force. Why? Because who is accelerating this 1 kg? It is a spring force. So how to find it? I'll look into the 2 kg. Pulling force is what? 50. How do we write the equation? I'll again tell, pulling force or force along acceleration, like this, force along acceleration minus force opposite to acceleration is equal to simply mass into acceleration. Got it or not, Ryan? Is that clear or not? This is your equation. Don't bother about anything else. This equation you use, this is called as Anurag theorem. I created it. Newton didn't prescribe it. I told Newton that get lost. I don't know. So look over here. For 2 kg block, if I apply, what is my pulling force? 50. What is my opposing force? Spring force. And that is equal to mass 2 kg. Its acceleration is how much? 5. So this implies that spring force is going to be how much Newton? 5 to the 10, 50 minus 10. How much is that? 45 Newton. Are you able to get me or not? Huh? Acha, okay, yes. 40 Newton. Now, here, as you can see that on 1 kg, for 1 kg, if I look into that, there is no other force. Correct? Is there any other force on this 1 kg? No. So the simple idea is that spring force will provide you mass into acceleration. Spring force is 40. So this implies that that instant of time acceleration of that block is 40 meter per second square. Something is or no? Are you able to get me on? Is it clear or not? So simple idea. Always draw the spring forces. Now here you found out that this acceleration is different and this acceleration is different. The bodies are moving with two different accelerations in this scenario, in the spring forces. Are you able to get me or not? But yes, expansion and compression will be same over here. Let's suppose if I would have given k is equal to 50 Newton per meter, so I can find the expansion or compression directly. The value of expansion or compression, because you don't know what is really happening. Is that clear or not? They have two different acceleration, so you don't know what is really happening. Either they are in compressed state or either they are in expanded state. So whatever it is, the value of expansion and compression at this instant is simply F is equal to what? Kx. X is going to be how much? Force is 40 and K is how much? 50. So this is basically how much? 4 by 5 meters. Send me something else. Clear or not clear? Suji, clear हुआ? समझ में आया? This is the idea of spring forces. This is how you are going to draw spring force nature. Are you able to get me? Next, when I move ahead, second point of the spring force. Now, look over here. This spring force is used as spring balance, correct? Now, tell me. K is given 50 Newton, no? So if I place K as 50, so what I'll get? 4 by 5 only, no? I have given K is equal to 50 Newton. Now, second idea is a spring balance. When you consider a spring balances, what is the nature of a spring balances? Let's suppose if I consider any spring balance. See, a spring balance, what you are going to see that there is a spring and this spring is attached with a hook over here, and in this hook we attach the masses, correct? So in reality, look over here, what does it measures? If you look over here, let's suppose if I consider there is a weight over here, some weight. I don't know. See, it has some mass m, so it will have some weight over here mg. So in reality, our spring force is measuring what? Our spring force is measuring the weight of the body or not? Means what is spring? If I say something like a reading of a spring balance, if someone notes, so reading of a spring balance is nothing but simply equal to what? It is my spring force. Spring force at what time? Spring force at equilibrium state, or you should write at steady state. Later on, I'll make you understand what is this word steady state means. Okay, you can say that it is at equilibrium state. Say me something, yes or no? What is my reading of spring balance? It should be the force present during which state of the body? Equilibrium state of the body. Now, let's suppose I took some example. Idea is that, let's suppose if I attach this spring balance between two blocks or inclined plane or something like that. So, when, second point I'll write, when a spring is used when a spring is used with the some thread or or with pulleys, then mostly treat spring force and tension force as same. Mostly treat your spring force and tension force as what kind of balak? Same kind of force. Are you able to get me or not? Is that clear or not clear? Means if I use any kind of spring with some kind of a thread or pulleys, then what I have to treat them? I have to just treat them as similar kind of forces. Are you able to get me or not? So this is the nature of spring forces. When I consider spring forces, first idea is that, sir, it is away from the point of contact and present on the body, present on the spring, and spring balance is going to read your weight of the body, but that weight is exactly equal to whatever spring force at the equilibrium state of the body. So let's take some example based on this. Okay, like let's suppose if I consider a lift and I attach some spring over here, and with this I attach a block of mass. Got it or not? Okay. Now I asked you find the, like, this is a reading. This is a basically uh, spring balance. Got it or not? Which will read the reading. Now question is very simple. Find the reading of spring balance when the lift first goes up with acceleration a naught, second goes down with acceleration n. Got the idea or not? And third goes down with acceleration a is equal to c. Tell me fast, what is the answer? Tell me fast, fast. Yes. So in first case, if it goes up, like if I draw the FBD of mass m. Now tell me, the mass m is in accelerating frame or non-accelerating frame? Balak, accelerating frame means if I consider lift, श्रुचि समझ में आ रहा है ना? Mic on. Hello. हाँ, देख, means if I consider the lift to go with acceleration a naught, basically this means that it is which kind of a frame? Accelerating frame. And in accelerating frame, look over here, its weight is how much? Mg. Now, away from the body towards the point of contact, if I draw, the spring force will always act in which direction? For the mass m, it will be acting in upward direction. So this will be my spring force direction, correct? This is my which force? Spring force. Now, if string means lift goes with acceleration a naught, then the mass m will feel a pseudo force in the accelerating frame. You know that, and that is going to be how much? M a naught. So therefore, in first scenario, reading of spring balance at equilibrium, Fs is going to be how much? M g plus how much? A naught. Same something as a no. If I consider the second scenario, how much is that? Alright, reply me guys. M into g minus a naught. सोचिए बेटा, रिप्लाई भी कर दे. So look over here. This is how much mg. This is what spring force. Now the lift goes down. So pseudo force on this mass M will be present in which direction? Upward direction. So this is going to be m a naught. This is mg. This is a spring force. So spring force is going to be how much? M g minus how much? A naught. And in third scenario, if A is equal to z, then this implies what? Spring force is going to be how much? According to this downward frame formula, spring force is going to be 0. Are you able to get me or not? Clear or not clear? Suji, clear? Second, second is not clear. Simple idea. Look over here. Weight is how much? Mg. The lift goes where? Upwards with acceleration how much? A naught. Sorry, down with a naught. So the pseudo force on this mass M will be present in which direction? Upward direction or not? Okay, so then I can write the equation as what? Total upward force. I have told you to write the answer at what state? Equilibrium state now to find the reading. So this means that total upward force is equal to downward force. So Fs plus m n naught is equal to what? Mg. What it will give me? Fs is equal to mg minus m n naught. Is that clear or not? And this is why in third case it is 0. Are you able to get me or not? Clear or not clear? Okay. Can you understand me? Is this clear? 1 minute. Just I'll open some of my great contents of Anurag sir. Okay. Next part, let's try some more question, and then I'll move to the depth of this. Okay. Let's be fast a little bit. Look over here. Let's suppose there is a table. Okay. Attached with pulleys. Or not. And I took two blocks on it. And attached to these pulleys. And in between that, there is this spring balance. 1 minute. There is this spring balance. Means, and this mass is 5 kg. And this mass is 2 kg. Okay. Then question is, find the reading of spring balance over here. If every surface is smooth, okay. Find the reading of spring balance. Be fast. Imagine where the body will accelerate. Hmm. 30 Newton. सुरुचि कितना? अच्छा, let's first of all, Ryan, any answer? Let's draw the FBD. See, any question goes through FBD, correct? Your task is to draw FBD. This is mass, how much? 5G. There is one tension, as there is a breakage over here. So I'll treat it like two threads. So there will be two tensions. Now T1, this is T1, T1, and this is T1. On this side, T1, correct. This side, sorry, T2, sorry, sir, not T2, T1. This is the total number of forces which we have to draw, correct. Now, inside, if you look on the spring, then opposite of this T2, there is a spring force, and opposite of this T1, there is a spring force, correct. As I have told you that here in this chapter, we are not considering any kind of mass of the spring. So what will happen? As there is no mass of a spring, this T1 is exactly going to be what, Balak? T2, and spring force only will be 1 over here. Same something else. Now you got the clear ideas or not? Now, which one is heavier block, 5 kg or not? So the whole system will be pulled down along which direction? Along the direction of 5 kg. Are you able to get me? Clear? What is this acceleration? Total pulling force. If you look over here, this whole system is pulled by this, just wait, 5g or not? Say something else or not? So 5g minus this whole system. See, T1 T1 cancel, this T1 T1 cancel, T2 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 all cancel, spring force all cancel. So it is just opposed by how much? 2g or not? Divided by how much mass is moving? 5 plus 2, 7. So this is how much? 30 by 7 meter per second square. Got the idea? सुरुचि क्लियर? जगी है ना? सो रही है क्या? हाँ आ रही आ रही. तो look over here. So I got acceleration. So basically, this is spring force in equilibrium state is either equal to any one of the tensions or not, T1 or T2. But T1 and T2 are same, so it will just change to T over here. Same something as no. So therefore, I can say now, reading of spring balance over here is simply equal to tension T. Means if there is no mass of the spring, then you have to assume that whatever tension is there, that is my spring balance reading. Are you able to get me or not? So therefore, 50 Newton. Let us check. So let us apply in. Let us find this tension in any of the block. So I let's suppose if I look for 5 kg, for 5 kg block. If I look, pulling force is how much? 5g. Opposing force is tension T, and that is what? 5 into it. So therefore, T is equal to how much? Simply 5g minus 5 into 30 by 7. How much is this? 50 into 7 is 350, no? Minus 5 3 is a 15. Divided by how much? 7. So therefore, this is how much? 200 by 7 Newton. Or you can say reading This is my reading of spring balance. Got the idea? Clear or not clear? Clear? Can I give one more question? एक और क्वेश्चन लगाते हैं, उसके बाद दूसरा कॉन्सेप्ट आएंगे, ठीक है? And you complete these lectures in the evening, okay? Got it or not? Because today I'll be, after you go, there are so many things I'll be doing. Is that clear? Uh, no problem. Let's suppose there is a block attached over here. Another block is over here. I don't know. And then there is a pulley over here. Now, this block is attached with this pulley, and this block this pulley is attached with the, means this pulley and block is attached with one of the spring balance. Okay, got it? Clear or not? Question is very simple. This is angle of inclination 37 degree. This is 5 kg once again, and this is again 2 kg. Again same thing. Find the, if every surface is smooth, this is smooth. Find the reading of a spring balance. So again you have to find what over here? Tell me fast. Yes. Yes. So what you have to find? Tension. Clear idea. Find the tension in this. Means you can, what you can do is simply remove this. You can just simply remove this. If you want to, if you are getting confused between these 2 points, simply remove this and attach a thread over there. Is that clear or not? And then simply find the tension in that thread. Okay. Hello, 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 hello. Can you hear me? Hello, hello. Okay, okay. Can you hear me? Hello, hello. Okay. Now look over here. Uh, so I have to find the reading of the spring balance. Again, same thing, same idea is there. First, find the acceleration. See, to solve this again, I'm using one method. I'm again looking into one thing. I'm looking into total amount of pulling force and total amount of opposing forces. Is that clear or not? So this is how much? 2g sine 37. Let us see. Look over here. If you draw the tension, this is going to be tension T. This is tension T. This is tension T. This is tension T. Correct? Correct or not? Net tension again is how much? Cancelled. So acceleration is what? Total pulling force. Heavier mass is 5g. If you look over here, 2g sine 37. How much is that? 2 into 10 into 3 by 5. How much is that? Tell me fast. 5 to the 10. 3 to the 6 to the 12. 12. And this is how much? 50. Which one is heavier? 50 now. So which one will pull? 5g. So equation will be what? Pulling force minus whole thing is opposed by this 2g sine 37 or not. Divided by with these forces, how many masses are moving? How many masses? 2 kg and 5 kg. So 2 plus 5. Is that clear or not? So 50 minus 12 by 7. How much is this? Uh, 38 by 7. Now, let's suppose if I apply for 5 kg, for 5 kg, simple idea. Pulling force 5g minus opposing force tension T is equal to 5 into acceleration. So T is equal to 50 minus 5 into 38 by 7. That's your net tension. Is that clear or not? Are you able to get me? And that is your reading of spring balance. Okay, clear? So this one was the work done by forces of spring. Now what I'm going into right now is this is called as something cutting of spring, which is the most confusing problems of this whole spring series. Now to talk about this, I have a small point. See, first point is you have to remember what we say is, no, let us write in a star point, steric sign, that first point, springs are lazy guys. 1 minute. Wait. Springs are lazy guys. What does this word mean? What is the spelling of guy? G-U-Y, Z or S? क्या होता है बे? G-Y-U or G-U-Y? Okay, let's put like this. Springs are lazy guys, which means that their behavior remains as it is for some amount of time In another words, you can say that the forces on the spring does not change instantaneously. Does not change instantaneously. Are you able to get me or not? Say me something, yes or no? Clear or not clear? Okay. So let's take an example. I have first will not take spring. First, let's take an example of a thread. Okay. Let's suppose the thread I attach two blocks. Okay. Each of mass. Let's suppose this is mass 10 kg and this is mass 5 kg. So if I want to find, see, first of all, let's suppose if I want to find the tension in the thread, what I want to find, Balaks? Tension. See, if I try to draw the FBD, this is tension T, correct? Same tension. So as, okay, first of all, how many threads are there? One or two? Two threads are there, one here and another one over here. So this means that how many tensions I'll have? I'll have two tensions, correct or not? And the weight of the body is like this. Is that clear or not? So look over here. See, first of all, this is 5G. This is tension T1. This is also tension T1. This is going to be 10G. This is T2 and this is T2. So I can say that in equilibrium, the value of T1 let's suppose if I take this is thread 1 and this is thread 2. So in thread 1, if I want to find T1, okay, so T1 is going to be how much? Simply equal to 5G or not? Reply me, Balak, yes or no? And well, T2 will be how much? T1 plus 10G. How much is that? 50 plus 100, 150. Correct? Now this was my initial state. Which kind of a state? What I'm doing in final state, if final state is if thread 2 is cutted, what if sorry thread 1 is cutted, not thread 2? What I'm doing, Balaks? Thread 1 I cut this thread. When I cut this thread, what will happen? See, instantly my tension T1 means this tension T2, the tension in thread two will become instantly my tension in the thread T2 will become how much? Simply equal to 10G without any thinking. And tension T1 in the thread T1 in thread 1, T1 will become how much Newton? 0 Newton. Means what will happen? This implies 5 kg starts to fall with acceleration is equal to g meter per second square, and acceleration of 10 kg block at that instant of time will be how much? 0 meter per second square. Say me something, yes or no? Clear or not clear? This point? कोई तो कुछ बोलो, yes or no? Now, in same scenario, let's suppose if we cut the thread T2, if we, so क्या होगा? If we cut the thread 2, now what will happen? First, what will be value of tension T1? Tell me. I cut it this. Now the whole thing is not hold down. It will be 0. I am not holding it down. Is that clear or not? Even T2 will become how much? 0. And acceleration of both the blocks 10 kg and acceleration of 5 kg will be g meter per second square. They will fall with acceleration due to gravity. Is that clear or not? That's the meaning of cutting of the thread and cutting of the spring or something like that. Is that clear? First idea. Are you able to get me? Now, in this type of problem only, what I'm doing, I am, so look over here. Here, I found out that, let me have a conclusion of this. I found out that the tension forces, the tension force got changed instantaneously. Is that clear or not? As the external forces are changed. Are you able to get me? Now, look over here. What will happen? Same problem, same scenario. If I just replace this with the spring, with a spring, then what will happen? First find equilibrium state and then do cutting of one and part two. Tell me the acceleration in each case. Assume that first I'm cutting spring and second case I'm cutting second thread. Okay. So I'll draw the FBD. This is a spring force. This is again a spring force. Correct. So initially at steady state, means equilibrium state. What is my spring force? Spring force will be equal to 50 Newton and tension T is equal to how much? 150. Yes. Okay. So now case 1, when first one means when spring is cut. What will happen? When this spring is cutted, what will happen? So as you cut this spring, then look over here. Tension, see, spring force will instantly become, see, this is spring. As I have cutted the spring force will become how much? 0. So this means that acceleration of 5 kg will be how much? G meter per second square. And that will be downwards. Is that clear or not? Means if I cut this, Okay. Then this one does the free fall of g meter per second square. Are you able to get me or not? In case one. Is that clear? And at that time, tension will become how much? Just simply equal to 10 g. And acceleration, if we look into acceleration of 10 kg block, that will be still 0. Why? Because tension changes instantly its value. Same is only, no? Are you able to get me or not? Case 2. When the thread is cutted, then what will happen? When the thread is cutted, first of all, what force will become 0? Tension force will become how much, Balaks? 0. Correct, na? Yes or no? Tension force will become how much? 0. So if I look into the FBD of these, then what will happen? I'll have only these things. Control C. Look over. See. So in this, oh, hey, this block is my here. Is that clear? So now what is happening? I'll remove this. This is case 2. Okay. How I'll draw? Well, let me draw over here. Now see this. As this tension has become 0, got it or not? This is 10 kg. This is 5 kg. And if I draw the FBD of it, simple idea is there, sir. If I draw the FBD of it, look over here. This is how much? 5 kg. Then there is this spring force. There is this spring force, and this is how much? 10 kg. Correct. Now, as you know that, see, our answers over here are dependent on what factor? Our answers, we are looking at instantaneous state. Which kind of a state, Balaks? Instantaneous. So what is going to happen over here? As you cut the thread, only the thread is cutted. When you look into this spring force, what will happen? Spring force is not 0 at that instant of time. Can you get my point or not? What will happen to the spring force? Spring force will not change instantly to 0. Are you able to get me or not? Why? Because as we have said, springs are what kind of objects? Lazy guys. Means their forces will not change instantaneously. Means when you cut the thread, it will not change. But when I cut it, the spring, it got changed. Are you able to get me or not? Clear? So what will happen? Spring force will not become 0. And as spring force is not 0, Fs is how much? 50 Newton. And as Fs is 50 Newton, look over here. See, is this 50 Newton is balancing this 50 Newton. So if I look into the acceleration of 5 kg, this acceleration of this block is how much? Simply equal to 0 meter per second square. It is at rest at that instant of time. Acceleration of 5 kg will come as 0 meter per second square. Send me something, yes or no? But what happens to the acceleration of 10 kg? In 10 kg, there is a two forces which are acting. So acceleration of 10 kg is there. Why? Because there is two forces. Fs plus 10g divided by how much? Mass 10. 10 Fs is 50 plus this is 10g means 100, 150 by 10, which is how much? 15 meter per second square down. So this means that this one falls with 15 meter per second square rather than falling with acceleration due to gravity. So means something yes or no? And this is the meaning of the idea that springs are lazy objects. Their forces will not change instantly. And this is the nature, means you can imagine like this way. See, I cutted my spring. So see, I cutted my thread. So what should happen? First of all, this body should do the maximum compression, and then these two bodies will go down. Is that clear or not? Till that maximum compression happen, this one will be at what? Rest. Are you able to get me or not? Clear or not clear? So same type of question, a little bit change. This spring is in up part. Okay, clear? Same question, 10 kg, 5 kg. Case 1, thread is cutted. Case 2, spring is cutted. Tell me, acceleration and everything. Fast. Initially, what will happen? Spring force will be how much? Okay, first tension. Tension will be 50 Newton, and spring force will be how much? 150 Newton, correct? Then tell me, case 1, when the thread is cutted. As you cut the thread, tension will become how much? Tension. Yes, tension will become how much? 0. Correct. But again, but spring force will not change instantly. Correct now? Are you able to get me or not? Say me something yes or no. So tension will become 0. That is true. And if you look for the acceleration of 5 kg block, it will fall with acceleration due to gravity. Correct? Say me something yes or no. And if you look into the total picture, if you look into the total particular picture over here, see what is going to happen. If you look into the total picture over here, which force is not going to change instantly? Our spring force. Are you able to get me or not? And as spring force will not change instantly, question arises, this mass 5 kg starts to fall with g meter per second square. What is the acceleration of? Then 10 meter, 10 kg. This is 10 kg. So for 10 kg, simple idea, acceleration. Now look over here. Spring force is how much? If you look into the FBD of 10 kg now, spring force is there, upward direction, which is not changed, and that is how much Newton? 150. Or something is no. And only its weight will be present down or not, because tension is how much? 0. So this is 10g. So acceleration will be how much? Simple, spring force minus 10g divided by mass 10. So this is 150 minus 100 divided by how much? 10. 5 meter per second square. This is the idea. Means as you cut it instantly, the 10 kg block will be pulled upwards while the 5 kg block will go downwards. Are you able to get me or not? Clear or not clear? Is this clear? Discuss about case 2. Case 2. Now, when the spring is cutted, as the spring is cutted, what will happen? Instantly the tension will change its nature or not? Tension is like that Instagram. Instantly it will change its nature. Are you able to get me or not? So look over here. As the spring is cutted, spring force will become how much? 0. So as spring force will become 0, the both of them, this implies both blocks falls with acceleration due to gravity. Is that clear or not? Both blocks will start falling with acceleration due to gravity, and this implies also tension between the blocks is going to be how much? Is that clear? So what I found out the nature, springs does not change instantaneously, but tension changes. Say me something as well. Are you able to get me? Clear? Third type of this problem, which you have to do as homework today. Okay. Oh, sorry. 1 minute. Same type of question. 2 blocks, but only the springs. Okay. So this is 10 kg. This is 5 kg. Initial state, if first one is cutted, second spring is cutted. Let's suppose this is first spring and this is second spring. Then if I, in first case, if I cut the first spring, acceleration of both blocks. Second case, if I cut the second spring, then the acceleration of the both blocks. That is your homework for today. Is that clear? Tomorrow again we are going to meet. We'll try to solve 1 or 2 more questions of spring forces and nature of spring forces. And as we have seen this different work energy problems, so what we are going to do tomorrow, I'll introduce work done by spring forces and work done by gravity, and then we'll go to the depth of different work energy power problems. Is that clear or not clear? Okay.